Welcome to another Axini video. This one about testing technical systems, so communicative systems that 24/7 send inputs, receive outputs and keep on doing that, like systems in healthcare, railway systems, those kind of systems. In the previous video we explained how we do the modeling, visualization, exploration, stepping through your model. In this video we explain the testing part. So here you have the same door model that I showed before. So this is a model that we use also with students to explain the model-based testing. Here again the visualization. So it's a system that consists basically of three main states: closed, opened and locked. You can, from a closed state, you can open a door, you can then close it again, you can lock the door, you can unlock it, well, all those kind of operations. We have modeled it in our model, and now we're going to test it. So we press start. Now it's testing. It tests with 15 test cases, 30 steps deep. So as you can see, it's already finished, so it's really fast. Let's take one test case. And here you see that it now stepped through the system. It was in a closed state, it did a close, but well, a closed state you cannot close again, so it gives invalid operation. It did an open, system responded with opened, did a close, system responded with closed. So the question mark, those are the inputs for the system, and the exclamation marks are the outputs of the system. So here you see it try to lock. Well, let's see a visualization of the test case. So you see that it stepped through a lot of parts of the system already. It missed a couple of them. But this is only for one test case. So here you see them all together. But what now happens if you have a mistake in your system? Let's add a mistake on purpose. So we go back to the model, and here I prepared a line that said and let's now test with this. It's now testing again. And hey, now we also have failed test cases. So let's take this one. So this is another test case that I just showed. It starts in the closed state. Here it tries to unlock it, but well, you cannot unlock a closed door. Invalid operation, it tries to lock it. It says it's locked. Unlock it with the wrong passcode, invalid passcode, etc., etc. And then it does the close. And now the system responds back with invalid operation, and the model says, well, I actually expected to have closed here. And of course, this is the part I just changed. So let's go back to the model. Let's look at it, and here you see that instead of invalid operation, I now said, well, send it back closed. So I on purpose made an error in the model to show you how a failed test case would look like. And this is now exactly what happens in practice. So then you have the failed test case, you analyze it, you say, well, what could be happening here? You can just send the address to the developer and say, hey, can you also have a look at this? Together you look at it. Well, in this case, you of course find that you did a modeling error, you fix it, you test again. And this is basically how the testing works. You keep track of your coverage of the entire system. So how much states and transition coverage. And if necessary, you can configure parts. So your test derivation strategy. Here I chose one that tries to increase the state and transition coverage as much as possible, the data coverage as much as possible and as fast as possible. But there are also other test derivation strategies. You can set the number of test cases, the depth of the test cases, all those kind of things. So I tried to explain you in this video how the testing works. So first you model, until you feel confident that it's correct. Once your system is ready or your increment for your iteration is ready, you test it. Some test cases will pass, some of them will fail. You either fix your model or you fix your system until your coverage is on the level that you want, and your test cases are also the way you want them. And then you basically are ready to release your system. Thank you very much for watching this video.